video is the first of two on the rule of four. And just to make sure that you completely understand the rule of four, it's that there's four things whenever you're looking algebraically. You have the table. This is one thing. So you have your numbers, your x and your y, and you may have a process. You have your graph where you're plotting your coordinate plane, your coordinates. So like 2, 1, and 3, 2, and you plot those x and y on here. You have your situation, which is like your word problem that looks at what do you put in the table, then what do you put on the table to the graph. And whenever you have your numbers on the table, it's the fourth piece is the expression or the equation that is 2x plus 8, and this would be 7x. And so it's different for each table, but all of these should be the same for any one problem. So let's look at pieces of this. First, let's talk about some vocabulary and terminology, because one of the things I think is most difficult about algebra is that the same thing may have different names. So if you are looking at this table, we like to think of this x going here for this term, and then y going here. And then we call this part of the table the process column. And the process just means what's going on. Well, there's other names for these things that they still mean the same thing. It might be called input, and this would be output. And it's going through here, what changes x to y is the rule. And the rule goes in the middle. So you have the input, the rule, and the output. Or you could have the input, the process, and the output. Or you could have x, the rule, and y. And then another letter that might be used to represent x, really it could be any letter that is represented in the word problem, but another one that you see a lot of times is n. And so in this instance, like the rule here would be 9 minus n, and then y would be your output, and this is n being any number. So you would substitute in, let's say 7, and so it's 9 minus 7 would equal 2, and that would be your output. And so this is what's going on in the middle. If you were to write it, you would write 9 minus 7, and that's 7, and that's 2. And then we'll get into whenever the table is stretched out this way instead of up and down like this, you might look at the x, or the input is also called the position, and the output is called the value. And then this process and rule, you could also refer to that as the expression. This is the expression. And the most important thing, or one of the most important things to know about algebra, is the only thing that changes the expression into an equation is to add y equals. And you can have the expression over here. So the equation is y equals the expression. That's the only thing that makes an expression an equation is that equal sign. And that's that looking for this. So that kind of tells you and shows you all the different things that can be represented in the same way, but with different terms. And we're going to work through some problems, some examples. And this says Jenny earns $8 an hour. This is the situation. Jenny earns $8 an hour working part-time at the supermarket. Determine how much she will earn in each hours. Okay, so we're doing different variables. So we can go ahead and put our x here and our y here. Now in this it says h hours. That's what's changing is h hours. So instead of x, we're going to look at h. Okay? And we're going to go ahead and put a process in here. And this is our input. Oops. And this is our output. And then the process, we're looking at this, is $8 an hour. So if we started filling in some numbers, if she worked 1 hour, she would make $8. And that's $8 in 1 hour. If she worked 2 hours, she would make $8 for 2 hours, and that would equal 16. If she worked 3 hours, she would say 8 times 3 equals 24. Okay, so you can start to see that. So my rule, what's going on in here, or my expression, same thing, rule and expression, same thing, is 8 times h. The only thing that's changing is this h. The 8 staying the same. So my equation is just 8h. Y equals 8h, because that's what it's showing up here. And the last thing that you would want to do on this problem would be to set up your coordinate plane, x and y, your t-chart, to represent your x and y coordinates. So you've got 1 and 8, 2 and 16, 3 and 24, and you could continue this. And h is 8h. Okay, but on the coordinate graph, you would plot 1 over 8 up, 2 over 16 up, 3 over 24 up. But we don't have a graph here, so really we only have the expression, the table, and the situation. So we don't have the fourth piece, the graph. So this is the last example we're going to do today. Susan is 2 when her sister is 9. Susan is 5 when her sister is 12. Find Susan's sister's age, A, when Susan is in. Okay, so it's a lot here, but if we just break it down, and we're going to put X here, and Y here, and the input here, and the output here, and we're going to fill in some of these spaces. So Susan, it says when Susan is in, so that goes down here. Susan is in. So Susan is 2, and her sister is 9, and Susan is 5, and her sister is 12. So what's going on in between here? We're not multiplying, because you don't multiply 2 times anything to get 9. You don't multiply 5 times the whole number to get 12. You're not dividing, you're going up. So you're going up by addition. So how much are you going up by? Well, you're going up by 7. So n plus 7, and so my rule is n plus 7, and my and then I can fill this in. So if I wanted to say, okay, in 1, whenever Susan was 1 plus 7 equals 8. And whenever she's 2, 2 plus 7 equals 9. And whenever she's 3, 3 plus 7 equals 10. And then I jump to 5, 5 plus 7 equals 12. And so my rule for n is any number plus 7 equals y. And so my expression is this, and my equation is just this, y equals, and that's my equation. So equation is y equals, expression is n plus 7. So that gives you a picture. So this is the situation, this is the table, and this is the equation or expression, and then I'm going to label my x and my y. So 1 and 8, 2 and 9, 3 and 10, 5 and 12, and then I'm going to graph it. 1 and 8, 2 and 9, 3 and 10, and then my graph doesn't go any higher. So it's this line right here. So that gives you what's going on. And it's just based on doing the math here. So this is the first video for Rule of 4. Later in the week, you'll watch the second video for Rule of 4 and see some more examples.